What is the unit digit of n to the power p plus 1, where n is a positive integer and p is the prime number greater than 3? Okay, p is a prime number greater than 3, so the possible values of p could be 5, 7, 11, 13, 17, etc. To answer this question, we need to know the cyclicity, so let me just quickly summarize the cyclicity. If there is any number which has unit digit 2, 3, 7 or 8, then the cyclicity of the unit digit will be 4. That means after every 4 powers the unit digit repeats. If the unit digit of the numbers are 0, 1, 5, 6, then the cyclicity is 1. That means that every power gives us the same unit digit, and if the unit digits are 4 and 9, then the cyclicity is 2. So these are the cyclicities of the unit digits. Now we have to quickly come back to the question and see. To answer this question, the first thing that we need to know is what is n, or the unit digit of n, and what is p. Now let's look at the first statement. The first statement says that when p is divided by 3, the remainder is 2. Okay, the remainder when p is divided by 3 is equal to 2. So according to this statement, the value of p can be equal to either 3 plus 2, 5, or 8, or 11, or 14, or 17, or 20, or 23, etc. But we can't take all these values of p because we already know that p is a prime number. So we can rule out all the non-prime values out of them, and finally we are left with the only acceptable prime values of p as 5, 11, 17, 23, or more such numbers which will be prime further. But is this statement sufficient? The answer is clearly no, because we have no information about n. Therefore we say that the first statement alone is not sufficient to answer the question, and at this stage we can eliminate option A and option D. Now coming to the second statement. The second statement here says that when n is divided by 10, the 10th digit of the resulting number is 9. Alright, let's see it again. When n is divided by 10, the 10th digit, that means the 10th digit is the first digit to the right of the decimal, is 9. That means when n is divided by 10, the result is equal to a dot 9 something. That means this digit is being confirmed as 9, which is clearly that if n is written, the 10th digit is 9, but we don't know anything about any other digit, but we can understand that n according to this should be equal to a9, because this digit must be 9, but we don't know if there is anything other. But the question, does it say that it's an integer? What is the unit digit of n to the power p plus 1? N is a positive integer. Alright, so we understand that n is a number which has unit digit 9. Now that the unit digit of n is 9, we understand that the cyclicity is 2. The cyclicity is 2, that means for every odd power of 9, because you see 9 to the power 1 is 9, 9 squared is 81, 9 to the power 3 is 729. That means that for every odd power, for 9 to the power 5 as well, the unit digit will be 9. The second statement confirms that since n has unit digit 9 and the power of n, p plus 1, is definitely odd because p is a prime number. P is a prime number greater than 3, that means p plus 1 is definitely even. So we can confirm that for every even power of 9, the unit digit is going to be 1, which means the second statement confirms that the unit digit of n to the power p plus 1 for any value of p has to be 1. Therefore, the second statement alone is sufficient, and answer to the question becomes option B. Thank you so much.